Okay, we're going to continue with Unit 4, Lesson 9. We're going to do problems 9.2. We have three right triangles here, and we are asked to find all the missing side lengths and the missing angle measures. So first, let's look at triangle ABC here on the left. I need to find the missing side lengths and the missing angle measures. I notice that I am missing a leg in my first triangle, but I have the other two sides, and that's good news because in a right triangle, the sum of the squares of the legs of any right triangle is equal to the square of the hypotenuse. So I can just square the lengths of the legs, so x squared plus 9 squared, that should equal the square of the hypotenuse. A little bit of algebra here. X squared plus 9 squared is now 81, is equal to 100. I'm going to subtract 81 from both sides in order to isolate my variable. X squared is equal to 19. Now I got to take the square root of both sides. X is equal to whatever the square root of 19 is. So I come to my calculator and I find out what is the square root of 19, and I get, I didn't want to delete that, and I get 4.36. So 4.36 is my x value. Okay, so I found the side length. Now I need to find the missing angles. Let's start here with angle C. Couple of things you want to think about when you're solving for angle measures. First is, I don't want to use this side length that I just solved for. And the reason for that is, if any of these calculations down here on the bottom are incorrect, that would make my measure of angle C incorrect as well. So I want to avoid that. So I want to use the side lengths that I'm given. Here's my angle C. I notice that here is the leg opposite angle C, and I also have the hypotenuse in this right triangle. So thinking about SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Thinking about SOHCAHTOA, I need to find out opposite and hypotenuse. Well, they go together with sine. So I know that the sine of angle C is equal to the length of the side opposite angle C divided by the hypotenuse. Perfect. Okay, now we're going to use a new math function. It's called arcsine, and all arcsine does is, just like subtraction undoes addition and division undoes multiplication, doing arcsine will undo sine. So on the left-hand side here, I take arcsine. Some people call it sine inverse, and actually I usually call it sine inverse, but the authors of this program wanted to use arcsine, so I'm going to try to do that, but I'll probably end up just calling it sine inverse. Now, the nice thing here is this sine inverse undoes or cancels this sine. And look what happens when those two cancel. I'm just left with the measure of angle C all by itself. And the measure of angle C then is going to be equal to whatever the arcsine of 9 over 10 is. Okay, so now I can just use my calculator to figure out what is the measure of angle C. So angle C is going to be equal to whatever the arcsine of 9 over 10 is. Now arcsine, notice, is the second function of the sine button. So I hit second sine, and it brings up the arcsine. I want the arcsine of 9/10. Enter, and I get 64.15. We round usually to the nearest whole degree, so we will call this a 64-degree angle for angle C. Now I need to find angle B, okay? And I can remember that the acute angles in any right triangle must sum to 90. So then angle B is going to be whatever 90 minus 64 is. Angle B will be 26 degrees. So now I've found angle B, I found angle C, and I have found the missing side length. Okay, moving on to our second triangle here. We have a similar setup. First, I'm going to find this missing side length. I notice that it's the hypotenuse, and I know that the sum of the squares of the legs of any right triangle is equal to the square of the hypotenuse. So 5 squared plus 6 squared, the sum of the squares of the legs, is equal to the square of the hypotenuse. 5 squared is 25, 6 squared is 36. That's equal to x squared. 25 and 36 is 61. So now I need to take the square root of both sides to get the x by itself. So x is going to be whatever the square root of 61 is. So I got to do square root 61. 7.81 is my value for x. Okay, so I found a missing side length. Now what I need to do is I need to find a missing angle. So let's start angle G. We'll find the measure of angle G. I notice, remember, I don't want to use the side length that I solved for, so I'm going to use this opposite leg and this adjacent leg. And then remembering up here SOHCAHTOA, tangent is opposite over adjacent. So then I know that the tangent of angle G is equal to the length of the side opposite, which is 6, divided by the side adjacent, which is 5. So then in order to get angle G by itself, I'm going to do the same thing. I'm going to do arctangent. This arctangent cancels the tangent, and I'm left just with the measure of angle G on the left. That's going to be equal to whatever the arctangent is of 6 over 5. So now angle G is equal to, I find the arctangent, so second tangent gives me the arctangent, and I want it of the ratio 6 over 5, and I get a 50.19 degree angle, or 50 degrees. Now I know that the measure of angle J must be complementary or sum to 90, so angle J is going to be whatever 90 minus 50 is. Angle J will be 40 degrees. So I found the measure of angle J, I found the measure of angle G, and I found the missing hypotenuse. Okay, last but not least, I'm on to my final right triangle, triangle DEF. I notice that I am missing a leg, so I do Pythagorean theorem again. Pythagorean theorem tells me that the sum of the squares of the legs of any right triangle is equal to the square of the hypotenuse. So then x squared plus 4 squared is now 16 is equal to 49. Subtract 16 from both sides to isolate my variable. X squared is equal to 33. Now I need to take the square root of both sides, so x is going to be equal to whatever the square root of 33 is. And I get 5.74. units. Okay, now what I want to do is I want to find my missing angle. We will start with angle D. And again, I don't want to use the side length that I solved for. So I notice if this is my angle D, this is the adjacent leg, and DE is, of course, the hypotenuse. So then I look up at SOHCAHTOA, which one puts adjacent and hypotenuse together. Well, it's cosine. So then I know that the cosine of angle D is equal to the length of the side adjacent, 4, divided by the length of the hypotenuse. Then I do the same thing. I want to get rid of this cosine, so I'm going to use arc cosine. Apply it to both sides. This arc cosine cancels the cosine, and I get the measure of angle D is equal to whatever the arc cosine is of the ratio 4/7. Now I can use my calculator, and I find the arc cosine of 4/7. And I get 55 degrees. So the measure of angle D is 55 degrees. Now, last but not least, I am looking for angle E. I know that those two acute angles must be complementary. So then angle E must be whatever 90 minus 55 is. Angle E must be 35 degrees. So this is really just about recognizing and being able to use the inverse of the sine ratio, cosine ratio, and tangent ratio. So if we're looking for an angle, we're going to use arc sine, arc cosine, arc tangent. When we're looking for side lengths, then we would use sine, cosine, and tangent.